This is Young Jogo, working at ETRI and also working as chairman of 6G Technology Committee, 6G Forum in Korea. First of all, I'm glad to be here to present our views on 6G. So my talk is about 6G R&D status and plans in Korea, mostly from our research institute perspective. But I believe the most of the contents that I am presenting today has a fairly good alignment with views from other major players in Korea. So I'll start with the nationwide 6G project in Korea. The first phase of 6G research on a national scale started in 2021 and will continue until the next year, 2025. And this first phase 6G research is centered around the 6 technology themes as shown here: performance, broadband, precision, and three-dimensional space, etc. And I think this project is focusing on two key areas. So one is utilizing very high frequency bands, that is sub-terahertz bands, for achieving a very high data rate with target peak data rate of 1 terabps. And another focus is so-called three-dimensional spatial communication, basically expanding the coverage of wireless connectivity by utilizing satellite-based non-terrestrial networks. The second phase of 6G research is going to start April this year, and this project shifts focus to relatively lower frequency bands, that is upper mid-band, emphasizing massive MIMO and Open RAN architecture, and AI-powered communication, and energy savings technology. So another important large-scale research project, which is at the preparation phase right now, is LEO satellite communication. This project focuses on developing a complete low Earth orbit satellite communication system. This project covers technologies for satellite payloads, high-throughput inter-satellite links, and advanced ground systems, including gateways and mobile terminals. The last year, the ITU finalized the 6G framework, and we have these 6 usage scenarios described by this wheel diagram, and 3 of them are extensions from 5G usage scenarios, and the rest 3 of them are new usage scenarios for 6G: ubiquitous connectivity, integrated AI and communication, and integrated sensing and communication. So regarding key capabilities, ITUR defined 15 capabilities, but different from 5G, the exact target values of some of these capabilities are not decided yet. They are to be determined in the technical performance requirement phase. So with this ITUR 6G framework agreement in mind, now I describe what we have in mind regarding key technology features for 6G. The first one is pervasive AI. So this is basically application of AI, extending its reach into air interfaces and radio networks. Specifically, we anticipate AI integration in CSI feedback, beam management, positioning accuracy enhancement, and self-organizing networks. Another promising area is integrated sensing and communication. So ISAC is a recently emerging area and expected to become a major feature of 6G. So by merging communication and sensing capabilities, ISAC will enable the system to understand their environment while transmitting data. Specifically, ISAC can be used for high precision positioning and estimation of range, velocity, and the angle of a target object. And it can be also used in the detection of objects' presence and the creation of images and maps of the surrounding environment. Related to the 6G usage scenario, ubiquitous connectivity, we believe the close interworking of TN, terrestrial network, and NTN, non-terrestrial network, will become an important feature of 6G. So key research areas include TN-NTN networking protocols, enabling smooth integration of ground and satellite networks, including seamless handovers between them. And long-range high Doppler radio access technologies addressing challenges posed by large distances and varying satellite speeds. And robust satellite payload components designed to withstand harsh extreme space environments. So regarding spectrum usage in 6G, first of all, we need more spectrum to support ever-increasing traffic demand. We basically support multi-layered spectrum approach. So that is high band, such as millimeter wave and sub-terahertz bands, are used for sensing and ultra capacity, and upper mid-band 7 to 24 gigahertz frequency range used for coverage and extreme capacity, and the mid-band for coverage and capacity, and low band below 1 gigahertz for extended coverage. So regarding the upper mid-bands, there are 3 candidate frequency bands that are considered in Korea, as shown here. Around the 7 to 8 and 12 to 13 and 14 to 15 gigahertz. To maximize data rates and capacity, we think we will need at least 400 megahertz in the upper mid-band. And furthermore, 6G is expected to adopt advanced duplex technology such as in-band full duplex for improved spectral efficiency. Now I'd like to describe the current technology development in our ongoing 6G project. In the radio side, the sub-terahertz radio access is being studied as part of the first phase 6G research project. The target frequency range is 100 to 300 gigahertz. And the main focus is developing multi-point transmission and reception and waveform suitable for these high frequency bands, and also overcoming RF impairments. And we have developed a POC system and demonstrated 1 gigabps peak rate at the end of last year. And although interest in lower frequency is rising, we think sub-terahertz radio access remains a compelling component of 6G due to its unique advantages, such as providing a very high data rate in hotspots and wireless backward connection, and potentially very accurate sensing capability. And regarding wireline networking, we think the key feature of 6G will be a time-deterministic packet transmission for large-scale networks. So in order to realize real-time interactive service in 6G, we need to guarantee the total latency in communication, which is end-to-end latency, including both wireless and wireline networking. So we've been developing time-deterministic network technologies such as TSN and DNS since 2019. And we are now standardizing for internet-scale networks and developing a 100 gigabps packet forwarding engine. In 2025, we are planning a POC for hyper-immersive interactive service. Regarding NTN, we are researching dual steer, which is technology for TN and NTN multi-connectivity. ETRI is actively engaged in the standardization of dual steer technology, which is being carried out by 3GPP SA. In addition, we are developing network optimization simulator considering the LEO satellite constellation environments. And we plan to use this simulator to perform various performance analyses, such as multi-hop routing, inter-satellite handover, etc. And we are also studying a satellite clustering technology to improve the throughput of LEO satellite. Now I briefly describe our future research topics for 6G. So which are grouped into 2 parts, terrestrial and non-terrestrial parts. And note that these topics correspond to major R&D topics in the second phase of 6G research in Korea. So regarding non-terrestrial part, the emphasis on technologies for satellite payload components for NTN, specifically payload RF, payload antenna technology, such as multi-beam phase array antenna and beamforming, and modem and software to operate on the LEO onboard processor and inter-satellite link laser communication. Regarding terrestrial part of wireless communication, the prominent research topic is upper mid-band extreme massive MIMO, which has thousands of antenna elements for enhanced capacity and coverage. And we also planning to conduct research in AI-powered virtual LAN and low-fi modem for open LAN and integration of sensing and communication. Furthermore, we plan to develop coverage extension technologies such as RIS, NCR, and full duplex. Finally, I'd like to share our plans for 6G POC demonstrations in 2025. So one is demonstration of ultra high resolution immersive interactive service, where the wireless network aims for up to 200 Gbps data rate, while the wireline networking targets ultra low latency of 5 milliseconds over a distance of 800 kilometers. Another POC is gigabps level TNN and TN integration, which involves terminals simultaneously communicating with the cellular base station and a low Earth orbit satellite. Since the launching of LEO satellite may not be feasible until 2025, the satellite part will be emulated in this demonstration. Okay, this is the pretty much of what I have to say today. Thank you very much for your attention.